Okay, so for this we're gonna run through the maps. We're gonna add pins to it, and then we're also going to add GPS locations to the map so that we can display pins at that GPS location. So as I showed you last class, we're going to add a map to the view, and then we're going to enter a little code in here and show you how to do that. So for most of the projects, you'll probably start, unless you know you want to start with a tabbed application or page-based application, we're just going to start with a single view application. I'm going to name it VSU Maps. Make sure that Swift and Universal selected. These don't really matter that much. I don't like to have core data on by default just because it adds a whole bunch of overhead, though that usually does not get compiled into your application. And okay, so we'll drop it in there. It's fine. Okay, so if you guys have your computers in front of you, you can follow along. We've gone through this a million times, but just to reiterate what we talked about last time so that you enable the maps. The old-fashioned way was to go down and link the Mapkit framework manually. You just type in Mapkit here, and then you select it and add it. However, I'm just going to go ahead and click on the capabilities. Down here, Maps, and then just turn on that Maps. I can hit the button. Go back to General, just check, and sure enough, our Mapkit framework is automatically entered in there. So again, that's just a nice, better way of enabling that functionality, that capability within your application. Okay, so we go to our main storyboard. Again, this is where we edit our UI. And then down here in the right-hand corner, we have all these widgets and classes and controllers and whatnot to add. There is, in the bottom right-hand corner, hopefully you can see that, a filter or a search box. And I'm going to type in map, and it's going to filter all those options down and just give me the items that contain map within the string, and there's only one. Just drag this in here. Center it, maybe put it at the top. Drag this to the corner. And drag this over until it fills the entire screen. And actually I'm going to fill this up past the status bar here. So you can see that it's underneath that battery icon. If you want to go ahead and change that, you can click on your controller and you can have all sorts of different kind of layouts for your top bar. For the top bar here, we can do a translucent navigation bar, and I'll show you where that area is. This is not where you add it, it's just adding the layout so that you can kind of gauge what that's going to look like. You can have an opaque one, a navigation bar with prompt. So the navigation bar with prompt is a little bit bigger, so you have to account for that because my view now has just been pushed down. So let's turn that off real quick. Select this view here, and then I'm just going to say that it is inferred, meaning, well, it's inferred from Xcode's point of view what the view is going to look like. But you can play around with that. You can have different iPhone sizes from the iPhone 5.5, which is kind of tall, skinny and tall, to the latest, or actually, excuse me, that is the latest, to the earliest, iPhone 3 to I think the 4, not the 4S, yes, up to the 4S had this size screen. So you can see it's a lot tinier than what we're working with. But again, I'm going to put that back to inferred. And then, so again, to make this auto size properly, I can control click from here and kind of try to get these edges on here. But since there are no edges because my view goes all the way to the top and bottom and left and right, it's a lot easier to do it from this screen here. And if you don't see that screen, you can hit this little button here on the bottom. I don't know if you can see that, but it's way over here in the bottom left-hand corner of this view. So you click that, that'll open that up, just in case you don't see it. And then from here, control click up to my parent view, because it's going to expand within that parent view. And I'm going to do leading space to container. Control click drag trailing space to container. Control click drag vertical space to top and then bottom. Okay, so that should set up our map view like we did last class. Let's hit Command R to compile that, run our simulator. To make sure this is in the foreground. Give it a second to load up, compile, install, and run. I did this last time, didn't it? You had to like reload it. Yeah, I don't know. If it doesn't load the first time, just recompile it. Okay, so this is great. It is centered us on the United States, but we want to add it to BSU. So we're going to have our camera zoom in there, but in order to do that, we need to set the GPS location for that. And there's a couple ways you can do that. You can, let's see, so the device, where am I looking for? Debug, excuse me. Debug location, you can set these different locations, and this will tell the device your current location is the Apple campus. Your current location is going to be a city bicycle ride, and I do believe this is around Cupertino. So it'll start on Apple campus, one infinite loop in Cupertino, California. And then it'll move at about 8 or 9, 10 miles an hour, whatever it is. And it'll vary. It'll go on the street. Or a city run. And so this is about, I don't know, 5, 6 miles an hour, however fast somebody runs. And then freeway, which is about 65, 70. And it goes on freeway, whatever freeway is outside Cupertino there or outside Apple campus. And it just starts driving. And you can access the GPS location of this simulator at all those various times. So if you run your app and you set your location here, the location will change and it'll tell you the speed and it'll go around. But what we also have here is the custom location, and so we can manually enter in, I'm at these coordinates, but what are those coordinates, right? It's just a whole bunch of numbers. So if you open up a web browser and just type in GPS coordinates, there's a bunch of different sites. I'm just going to choose the first one for simplicity. And of course, this is a different website than the one that I tested it out before, but that's okay. It all works the same. And actually, this one looks a little bit better than the one I used before. So this is, I'm just going to type in Boise ID, hit enter, get GPS coordinates. Now this is Boise's location, but what I want to do is get where we're currently at. And I can't see where I'm at, so I'm going to switch to satellite view. And try to figure out where we're at. We're
down a bit.
Yeah, 9th and Bannock, right? Or yeah, right there. Okay, so right where this parking lot is that where we are?
Yes.
Okay. Obviously it's not a parking lot anymore, but that's fine. So I am going to, and let's see, 61. So in this particular website, all the websites are different, but this one has it here for the latitude, and that's usually the first number. And so I can enter that in here. Oops, didn't want to rotate that. And enter it in here, but this is not going to do anything because we're not going to capture, sorry, I'm trying to, there we go. So this is how you tell your device, go to the user's current location. Okay, but I entered that in, it's not doing anything. We want to do this programmatically. When the application launches, we want it to zoom in on that building. So let's go over to Xcode. We're going to open up the assistant view up here in the right hand corner. So you saw me do this last class, but let's close Beach Ball of Death. There we go. Okay, so opening up that assistant will show me the code file for this particular view controller window here. Okay, so it corresponds again to this code over here on the right. And I'm going to control drag from my map view inside my class and make that a member of my class. I'm just going to call that map view. Hit enter. Make some space there. Hit save. It's complaining because it doesn't know what MK map view is. That just means we need to import the Mapkit module. Make some space there. Okay, so in our UI view controller classes, this is an overridden method. This override keyword shows that. And then we have the keyword func for function, and then view did load. If you're remembering back to the API that I covered at the beginning of class, we also do have a view will load to tell you that the view is going to load. Obviously, that happens before it does. And so you can maybe set up some additional code before the view is actually on the screen. Now, you can't do anything in that view that pertains to the UI, so if you want to set up buttons or whatever, that's best done here in the view did load. It doesn't mean that that's actually presented on the screen. There's another one called view did appear, and that's when it actually gets slapped onto the screen. And so you can set up buttons and set up your UI elements here in this view did load, and that'll happen before view will appear. View did appear. And so you'll see that throughout the API of Cocoa Touch specifically, that will denote that this is going to happen, this happened. And so you can set up your code depending upon when exactly you need that to happen. In our case, we want to set up our Mapkit, or excuse me, our map view. And so I have a reference to that called map view. And for this one, it's called set region. And let me, I think we're done with the storyboard here on the left, so let me switch to the code editor, but then I have to switch back to the view controller for that, so now I can fill up my screen. Okay, so, and then actually I'm going to do one more thing. I'm going to hit Command-0 to get rid of that sidebar, just so we're max real estate here. Okay, so when I said set region, the set region is the region of the screen that the map is showing. So what it's asking for as its first parameter is, what region do you want me to show? And so we have to set up a MK coordinate region for this. And so this is our first placeholder. And then the second placeholder is, do you want me to animate that change to this region? And that would be nice. So we're going to be zoomed out from the United States, and then we're going to zoom into Boise if we have this set to true. So let me just go ahead and hit true for now before I forget to do that. Not that I will, but... Okay, so what is this mysterious MK coordinate region that it's asking for? Well, Code Complete's really cool. So usually what I do when I run into a new API that I'm not used to is I'll just type it in, MK coordinate region. Okay, actually let me continue typing that out so we can coordinate region. Okay, so I've narrowed that filter down. It looks like I misspelled coordinate, but that's okay because obviously Xcode figured out that I missed an O, and I was like, I knew what you meant. And that's great because I misspell stuff all the time. We have, what, 5 different options here. So this is just the class. These 2 top ones are just the class. This is if you're not used to maybe functional programming, or you're specifically only used to object-oriented, this is a function, not a method. Sometimes I use them intermixed or interchangeably, but this is actually a function. It's not attached to a class. It's just kind of floating out in the namespace here somewhere as part of the Mapkit module that we've imported. And so we're not going to do a class dot whatever or an instance dot whatever. This is just going to be a function that lives out or is defined kind of in space. So hopefully that does not confuse you, but sometimes it does confuse people if you're only used to Java, where everything is attached to an object or a class. Okay, so we have this one, which is MK coordinate region make, and it's asking for 2 parameters. It's asking for a CL location coordinate 2D with a span of another object, MK coordinate span. Here's this one, where it's just asking for an MK map rectangle. And then finally, the 5th one at the bottom here, we're going to ask, this is the one we're going to use. This is MK coordinate region make with distance. So we want to make this object. This is kind of a constructor, but again, it's a function. It's not an initializer. It's not a constructor. It's just it's a function that makes an object. Kind of, if you study your design patterns, it's kind of a factory. So it's going to take some inputs out, and it's going to spit out. If you look on the left-hand side here, an MK region coordinate region, excuse me. So technically, you could probably use any one of these. These are just constructors with, if you use the parentheses, you create one of those. But we're going to go ahead and do this one. If you want to define the rectangle, you can use this one. If you want to say, I want to be centered on this one with a span of this, you can use that one. But again, we're just going to use this one for today. Okay, so first thing is first. It's asking me for a CL location coordinate. Now, if you're used to Java, you're probably used to this where, okay, it's asking for another object. I have to go ahead and create that object. Well, to create that object, I have to create another object. So you'll see a little bit of that here because it is object-oriented programming. So we always have to have objects. These things can't just come out of space. So how do we do this? We're going to say the object or the class that it's looking for is a CL location coordinate 2D. So we're going to type that in, CL location coordinate 2D. CL location coordinate 2D. Okay, so we have, again, our class constructions or our initializers. And we have another make function here. And so this make function is going to accept a CL location degrees and a CL location degrees for both the latitude and the longitude. Well, you're like, great, now I got to create another object. Well, not quite. So this is where Swift mixes a little bit with C, if you guys are familiar with C. These objects are just type declarations. CL location degrees, and I can prove that. I hope I'm right anyway. CL location degrees. If you type that out, you can actually see it's a double. It's not another object, it's not a class, it's just a double. So let me go ahead and get rid of that. As I said, it's just a type declaration. It's just saying this is a double. And the reason that we do this, why don't we just ask for a double, right? The reason that we do this is when we switch architectures or we switch, architectures, I mean from 32-bit to 64-bit or from Intel to PowerPC or from Intel to PIC or any of the processors on the market. Actually, I should bring up the A10 processor, the Apple processor that's in all of our Apple devices. When we switch between the Mac and the iOS devices and whatever, embedded Linux, whatever, Raspberry Pi, we may change that CL location degree type definition from a double to maybe a float because maybe we don't have doubles on whatever platform we're on. Or when we switch from a 32-bit to a 64-bit, you're obviously changing the number of bits for that double, and we can just do that at compiler time. You don't have to rewrite everything because your string might be too big when you try to compile that down to like a Raspberry Pi or something with a smaller processor. So that's why we use type declaration or type definitions for these classes. Okay, that was a long explanation to this. What is the latitude? Well, let me go back to our latitude and longitude here. Paste that in there, and that should be fine as is. And then copy this one for the latitude. Again, Control / we'll select our next placeholder. Paste that in. Okay, so I mean we got a whole bunch of placeholders here. So Control / latitudinal. Actually, what is that? Okay, yeah, latitudinal meters. What that means is along the latitudinal line, how many meters do you want to display? I was playing around with this before, and about 2,000 meters is actually, yeah, I think that's about right. So that's about 2 kilometers. That's fine. And again, that's how much of the map you want to show. If you're trying to show a football field, you'd probably be closer to 100 meters, right? But I kind of want to show this whole downtown area, so 2,000 meters longitudinally as well. And these are probably best set as constants somewhere, so let me just pull these out. Xcode had some really cool refactoring where I could just highlight that, select a button, or hit a keyboard shortcut, and it'll create a constant for me. But I'm just going to say distance span equals this. And I always recommend you do not, anytime you kind of see these coordinates in here or hard numbers, I always recommend that you do not hard code those in, but instead pull those out as, and this actually should be a double because that's what it's expecting. Or actually what I should do is a CL coordinate, shoot, what was the? Yeah, but it was the whole type declaration that I was talking about. Yeah, CL location degrees. Okay, so what I did was I went to the method here, and then just hit the escape on right after that E, and it'll show me the declaration for that, what it's looking for that method. So CL location degrees. Okay, so that is the type of my constant, again using that keyword let here. And so now that when I paste those in, everything should be fine. And again, for this coordinate make, I'm going to pull this out because I don't like a long whole lot of code. This is going to be a constant because it's not going to change. Actually going to say BSU CS campus location. I like to have really long names, as do most Cocoa and iOS developers. Actually, it comes more for Mac developers. I see new iOS developers still having those really short variable names. But whatever. So this is a, oh, I'm talking too much. What is it asking for? CL location coordinate 2D. Okay. CL location coordinate. Okay, and that just sets it to a constant. Except that it is complaining about something. Something about what is it asking about? Oh, I pulled out too much. Okay, sorry, I wasn't paying attention. Okay, so put that on one line, and then this is asking for, let me just go ahead and delete this and recreate it. Hit the escape key, select that. Okay, so I pulled that out, but this is why I try to use the tools, because I usually don't talk while I'm programming, but anyway. So the center coordinate is going to be this BSU CS campus coordinate location. Our longitudinal meters are going to be that distance span that I accidentally pulled out. And then control / selects the next placeholder, and again the distance span constant that we have in here. And expect this coordinate. Sorry, try to use your code complete as much as possible. Try to plan ahead when you're writing these out. I just wanted to show you kind of the workflow that sometimes happens when you're creating, you're trying to ask the map to do something. It's like, well, I need 3 other objects in order to do that. Okay, so that's kind of what we do. But here we go. So again, we're creating that span of about 2,000 meters. That's going to be the height and the width, essentially, of our map. It's going to be about 2 kilometers. Hopefully you guys are familiar with the metric system. And then our center location of where exactly on the map is the center of that map going to be. And it's going to be at basically wherever I put that pin. And then finally, we're telling the map view, set that region. So center in on this location with about a 2,000 meter height and width. However, our view is a lot taller than it is wide, so it's going to figure that out for me. Without further ado, let me just go ahead and compile that. Oops. Okay, so it did a pretty poor job of animating that, but that's okay. But it did center in on our location, but it didn't add a pin. So it's like, okay, where are you? So that's not very helpful at this moment, but we were able to zoom in on it, and you kind of did see it animated, but it was kind of slow. All right, so now we have to add pin annotations. And what I mentioned before is we don't usually subclass classes in Cocoa, but sometimes we have to. So to do that, Command 1 to show our view on the side here, we want to add a new Swift class. And this is just going to be a class that contains the pin's title, the location of that pin on the map, so it's another coordinate CL coordinate location, and a subtitle. And hopefully I can remember everything, but we have documentation to go through that. So to add another Swift class, there's a couple ways to do it. There's File, New, and then File down here, or you could just do the shortcut keyboard, Command N. Or you can go way at the bottom left-hand corner here. There's a little plus button. As long as you're on this screen with the files, hit that, and you can do a new file from here. It's going to ask you what type of file do you want to add. You can add an XML file, a JSON file, an image, whatever. I'm interested in Swift, so I'm going to add a Swift file. You can also add Objective-C if you want to include those and mix them with there. Okay, so for this one, we're going to call this, let's just call it BSU annotation. And annotation is another word for pin. No big deal, it's just what they call it. Okay, so it gives you pretty much a blank, empty file that doesn't really help us much. It's importing the foundation module, which, well, I don't really think we need, but I am going to insert the Mapkit, or import the Mapkit module. Now, this doesn't increase my file size. Xcode is really good about keeping it very, very small. So if I don't use anything in the Mapkit module, it doesn't increase the file size. It will, because it's increasing it, or it's including it in another file. But let's say I added, I don't know, core data or something like that, but I don't use any of the core data functionality. It won't include core data. But then again, it's a framework. But I don't know. It's it just depends on how you do it, what you use, and whether that increases your file size or not. And again, because we're on iOS, smaller devices, try to keep your files and your IPAs, which is the resulting binary file, or package I guess it is, as small as possible. Okay, so anyway, we're just going to go ahead and type in class and use your autocomplete. So the first one here is the Swift subclass. I want to do that. What's the name of it? Well, we called it BSU annotation, so we pretty much, well, we have to name it the same as the .swift file's name. So BSU annotation, BSU annotation, like that, so that this one here, again, matches that name there, minus the .swift, of course. Okay, so then it's asking for a superclass, the parent class that we're inheriting from. We want to get a lot of the kind of hierarchy objects that included with Cocoa, and so to do that is NSObject. That's very similar to Java's object, where you get that base kind of functionality with that. But we also want to inherit from MK annotation, because that's the Mapkit's annotation that we want to inherit from. So a little bit of multiple inheritance there, sort of. Okay, so then it's asking for some code. Now, I kind of know off the top of my head what this is. It's going to ask for a title, and it actually has to be named specifically title, and it has to be named, let's just go ahead and do that. It's a string. Actually, hold on a second. Code complete came up. So these are actually the ones that I do want, so I'm just going to let code complete help me out here. So title, :string question mark, meaning it's optional, var title, subtitle, excuse me, and var let's see, does coordinate, yeah, coordinate, sorry, I was going to call it location, but autocomplete knew what I was talking about. Now, if you didn't quite know those off the top of your head, you can hold down the Option key, or the Alt key, and click on the class MK annotation. So again, holding down Option, clicking on it will bring up this kind of quick help, and this is really nice because you can quickly see what this looks like, but this is almost never useful for me. What is useful is the reference at the bottom here, so this little tiny link at the bottom. If you click on that and you wait a second, it'll bring up Xcode's help. And probably most of you don't use help all that often, but I swear the Xcode one is actually really good, if it works. Let me try that again. This was working. Okay. Hey, if it doesn't, yeah, I'm still on the beta, by the way, so maybe that's a bug in the beta. Hopefully, we'll just assume that's true. Okay, so I brought up the documentation for MK annotation, and if you scroll down to the different values in here, we have coordinate. These are an attribute, of course. Set coordinate, that's a setter. And by the way, I forgot to mention this in the first class. When you declare members of your class, in this case, it would be, oops, it's the same window, title, subcoordinate, and coordinate. In Java, you have to set the getters and setters for those specifically, also in Objective-C. And usually you do that by doing some kind of keyboard shortcut or going to the menu and saying auto-generate these, right? It doesn't work that way in Swift. The getters and setters are actually automatically by the compiler created for you. And you can limit these to read-only or what are the other options? Read-only, like fully read and write, which would be getters and setters, or you can define a custom getter. And this is very similar to the way that C# does it. And let's see if I can do this without messing up. If I wanted to say, let's just make something up here. You know, map pin description or something like that, if I can spell description, and that's a string. What I can do is have that return maybe title, actually be a string, so / parentheses and parentheses, and maybe like the subtitle or maybe colon, something like this. And so this is a custom getter for this member. Excuse me. Okay, so that's how you do that if you're interested. And of course, you can look it up in the Swift book there. This is, well, it's going to complain that there's no initializer. So we're going to do init, and then we're going to set, I don't want a default initializer. I want to say title string, subtitle, also a string, and then coordinate, which is a CL location coordinate 2D item. And I'm going to say self, because we're referring to the members in this class. Title equals title, self, subtitle equals subtitle, meaning the second one is from the parameters, of course. Self coordinate equals coordinate. You don't want to know how we used to have to do this in Objective-C without auto reference counting. It was quite a beast. Okay, so anyway, but very efficient. Okay, so I've set up this subclass of mcanon annotation just so I can add a pin to my map. But that's pretty standard. You can use this subclass to add photos to your pin. So when you click on the pin, opens up the little window, you can add photos. And actually, you can add any UI view that you want. So you can put a table in there, you can put a web browser in that little window that pops up. I'll show you what that looks like in a second if you haven't seen it. But yeah, you can override this and show whatever you want. But we're not interested in that at the moment. But we are interested in creating one of those. So we don't have to import this. It's kind of like Java. It's all kind of in the same package where I can just reference our BSU annotation class that we just created. So I'm going to say let BSU, lowercase, BSU CS class location equals, and then this is going to be, actually it's not a location, it is a pin. It's an annotation, but I'll call it pin. BSU annotation, and then it does have that new initializer that we created, so title, substring, coordinate. I'm going to go ahead and select that. I'm just going to type in some basic stuff here, subtitle, and then coordinate. So if you remember, it's looking for a CL location coordinate 2D. Well, we actually have one of those, and that's great. So campus CS location, paste that in there. Okay, so we've created the pin, but we have to add it to the map view. So map view dot add annotation, and again, you can add a list of annotations if you want, or an array, which is denoted by this overridden method. I'm going to choose the first one because it's going to be a single annotation, and just pass that in there. BSU CS campus location. Okay, and it is complaining because I think it's asking for something slightly different. Oh, I'm sorry. It's the one above it. So the pin. I have to pass the pin. That's what happens when you talk and code at the same time. All right, so save that. Looks like everything initially ran okay. No errors. Switch over to our simulator. I don't know why it's so slow, but there's our pin. Okay, so a little bit of work to get the pin in there. But once we click on that, you can see title, subtitle, put it whatever you want. Of course, if you gave that a longer name, like what is it, CS402 mobile development class, and then the subtitle is greatest class on campus, right? Right? No? Close, pretty close. Of course, this sometimes the simulator pops up automatically, sometimes it doesn't. All right, so here's our pin, nothing changed, but when we do click on it, you can see that that window expands to the title of your pin. Okay, so that's how you add pins to the map. Now, obviously, if you wanted to add more pins, like if you were adding maybe restaurant locations or different buildings on campus with a pin. By the way, you can customize those pins. You can make them look like Pokemon. You can make them look like textbooks or little graduation caps or whatever you want to do. You can replace that by overriding some other methods within that map annotation class. What I was going to say is, if you wanted to add additional pins, you would either do that with a for loop, right? You would just have a whole bunch of, you would have an array of locations, so a whole bunch of GPS locations, stick that into an array, and then with a for loop, or actually you wouldn't need a for loop, you would create locations from those CL location coordinate 2D objects from those in an array, and then pass that array to the map view, and then the map view will just take care of adding all those pins. And of course you can remove those pins, etc., etc. But that's the basics. Okay, so hopefully that helps you guys out with project 1. I'm going to stop the